Hello everyone, welcome to the Gate Engineering online learning classes. In this video, we will discuss some problems on the Laplace transform, and this is the second part of the practice problem on the Laplace transform. And these problems will be going to help you in the GATE exam and PSU because all these problems are related to the Laplace transform properties. If you know the properties of the Laplace transform, then you can solve this problem very easily. So let's begin from the first problem. This is the first problem. We have given xt, which is nothing but the derivative of t e to the power minus t ut. So in this case, we have to compute the Laplace transform of xt and we have to find out the xs. We have given four options. We have given four options in this question. We have to check which one is the correct for this xt. So in this problem, we are going to apply three properties. One is the shifting in frequency. Second one is the t multiplication in time function. And third one is the derivative property. So let's begin from the right side. First, you check what is the Laplace transform of ut. You know the Laplace transform ut is, Laplace transform of ut is 1 divided by s. This is the Laplace transform of ut, which is 1 divided by s. And you also know the Laplace transform e to the power minus t ut, which is the multiplication in time by exponential, is nothing but the shifting in the frequency. E to the power minus t ut will become 1 divided by s plus 1. Because as you know, e to the power minus at ut is nothing but 1 divided by s plus a. So here a is equal to 1, so we can write it as 1 divided by s plus 1. Now we apply the property Laplace transform of t ut or t e to the power minus t ut, or we can write txt. Laplace transform of txt, as you know, Laplace transform of txt, as you know, this is nothing but the minus d over dsxs. So this is the derivative in frequency domain or s domain is the multiplication in xt with t. So this will be the xs, derivative of xs with respect to s and minus sign. So here, by solving this problem, taking the Laplace transform t to minus t to ut, you will get 1 divided by s plus 1 whole square. By taking the derivative of s plus 1 divided by s plus 1, you will get 1 divided by s plus 1 whole square. And we'll take the negative sign, so you will get the 1 divided by s plus 1 whole square. Okay, so now differentiation in the time domain is nothing but multiplication in the frequency domain by s, so it can be written as sx of s, where now we have xs is nothing but 1 divided by s plus 1 whole square. If we multiply this s with this xs or this term, we will get s divided by s plus 1 whole square. So option B is the correct for this problem. So for solving such kind of the problem, you should start from the right side. First, you take the Laplace transform of the right side, then you move to the left side. So in our case, first we started from the Laplace transform of ut, then we took the Laplace transform of e to the power minus t ut, then we took the Laplace transform of t e to the power minus t ut, then we took the Laplace transform of d over dt t e to the power minus t ut. So we use three properties in this problem. Now we are going to solve the second problem. In this problem, we have option B is the correct. This option B is the correct option for this problem. Now we are going to solve the second problem, in which we have to compute the Laplace transform of this function xt, which is convolved with two signals. One signal is x1t is u of t minus 1. This is our x1t, which is nothing but u of t minus 1. And second one is the e to the power minus 2t u of t minus 1. So this is our x2t. If we take the Laplace transform of ut minus 1, this is the time shifting property using in the ut minus 1. So its Laplace transform of ut minus 1, as we know, Laplace transform of ut is 1 divided by s. And we also know the Laplace transform of shifting property in time is multiplication in frequency domain. So it will become e to the power minus s. Similarly, from the right side, 1 divided by s e to the power minus s is the Laplace transform of ut minus 1. Now we have also given multiplication of e to the power minus 2t in ut minus 1. So this multiplication in time domain is the shifting in the frequency domain by 2. So we'll replace s by s plus 2 of this function u of t minus 1. So we will get 1 divided by s plus 2. We will get 1 divided by s plus 2 into e to power minus s plus 2. So this is the Laplace transform of e to the power minus 2t ut minus 1, and this one is the Laplace transform of ut minus 1. And we also know one property, which is convolution. Convolution in time domain is nothing but the multiplication in the frequency domain. If we multiply this x1s with x2s, we will get 1 divided by s into s plus 2, and multiplication with e to the power a minus 2 into s plus 1. We will get e to the power minus 2 into s plus 1. So in this problem, we have these four options, and as we can see, we have denominator. In denominator, we have s into s plus 2, and in numerator, we have e to the power minus 2 into s plus 1. So from here, we can see that option C is the correct. So for solving the convolution problem, first we take the Laplace transform of x1t and we take the Laplace transform of x2t, and then we multiply both of them. We can get the Laplace transform of xt, which is nothing but x of s. So option C is the correct for this question. Now come to the third problem. In this problem, we have a given transform pair xt, and which is Laplace transform is 2s divided by s square plus 2. And we have to find the Laplace transform ys of the signal yt, which is function of xt. We have a given 2t xt, which is equal to yt. We have to find the Laplace transform yt, which is the ys. And we know the Laplace transform of xt, which is 2s divided by s square plus 2. These are the four options that we have to see which one is the correct. Okay, so first we will see, we know the Laplace transform of txt from the time multiplication property in the signal txt, we know, which is the minus d over ds axis that we have already discussed in the first problem. And we know the xs. In this problem, we will take the Laplace. In this problem, we will take the derivative of the 2s divided by s square plus 2, and we'll multiply with minus. So if we take the derivative of 2s divided by s square plus 2, we will get in denominator it will become s square plus 2 square s square plus 2 square and s square plus 2 into 2 s denominator into derivative of 2s, that will become 2 minus numerator into derivative of denominator, so 2s into s square. So derivative of s square plus 2 will become 2s again. So after solving this, we will get 2s square from here minus 4s square from here, so you will get minus 2s square plus 4. And denominator is same. Denominator is same as s square plus 2 whole square. Okay, so now this is the derivative of xs, and we have to multiply this minus from the property. So we will get 4, we will get 2s square minus 4, 2s square minus 4 divided by s square plus 2 whole square. So this is the txt, Laplace transform of txt. So this is the Laplace transform of txt, but in this case we have to compute the Laplace transform of yt, which is the 2txt. So in this case we'll multiply with 2 for this function. So we will get Laplace transform of 2txt, and it will become 4s square minus 8 divided by s square plus 2 whole square. So from here we'll get 4s square minus 8. Here we'll see 4s square minus 8 divided by s square plus 2 whole square is satisfying the answer B. So option B is correct for this problem. And we have seen in this problem, we use the property txt, which is multiplication in time by t is the derivative of frequency by s. So we have done this problem. Now we'll come to the next and last problem of this tutorial or this video. We have a given signal xt, which is a convolved signal. We have given cos 3t u minus t, and other signal is the e to the power minus t ut. This is the ROC problem. We have to identify what is the ROC for this problem. And options for these problems are given in this options are given here. Now we have to see which one is the correct. So first we consider this is our x1t. We'll consider this is the x1t, and second one is the x2t. E to minus t ut is the x2t. Now we compute the Laplace transform of x1t, and we know u minus t is the left-sided signal. This is the one-sided signal and non-causal signal, because u of t is 0, u of minus t is 0 for t greater than 0, and u of minus t is 1 for t less than 0, or it is finite for negative value of t. So this is the non-causal signal. So its ROC will be Laplace transform of minus u minus t, as we know. Laplace transform minus u minus t, as we know, this is nothing but 1 divided by s. Sm as it is 1 Laplace transform ut, but here ROC is less than 0. And ROC for this case is real of s is less than 0. Because this is a non-causal signal, so left-sided signal, so ROC will be the left side of the pole value. So, and pole value at s equal to 0 in this case. Now, we know the Laplace transform of cos 3t, Laplace transform of cos omega t is the s divided by s square plus omega square. So, in this case, Laplace transform of cos 3t will be s divided by s square plus 9. S divided by s square plus 9. So, this is the Laplace transform of cos 3t ut. So, what we have a signal cos 3t u minus t. So, in this case, this is a non-causal signal. Its ROC will be real of s less than 0. Real of s less than 0. And minus sign will come because of this multiplication of minus u minus t. Multiplication of minus with u minus t. So, this is the Laplace transform of cos 3t u minus t is the minus s divided by s square plus 9. And real of s is less than 0. This is the Laplace transform of x1t. Now come to the x2t, which is Laplace transform 1 divided by s plus 1 that we have already seen. And it's this is the causal signal, so its ROC will be real of s greater than minus 1. Its ROC will be real of s greater than minus 1. So in this case, we can see that this is our, if we consider this is our pole 0 plane, one case one case ROC is greater than minus 1. In one case, ROC is greater than minus 1 for x2s, and in other case, ROC is less than 0. ROC is less than 0 for x1s. So in this case, you can see we have an overlapping area between minus 1 and 2. So overall ROC of this xt or xs will be between minus 1 and 0. Real of s greater than minus 1 and less than 0, because this is the overlapping area. We take the intersection of the ROC. So in this case, ROC is greater than minus 1 and less than 0. So option B and option C might be correct. But we have x1s and x2s, which is the minus s divided by s square plus 9, and x2s is the 1 divided by s plus 1. So multiplication in the frequency domain is the convolution in time domain. So we will multiply this function with 1 divided by s plus 1. So we will get minus s divided by s plus 1 into s square plus 9. So option C and option D might be correct from the transfer function, but option D is correct from the ROC. So overall option D is the correct here. So option D is correct, and we have seen today's 4 problem. All these problems are related to the property. If you are well good in the properties of the Laplace transform, you can apply the property and you can solve all the problem very easily. Thank you for watching this video.